So welcome everybody to this week's Gardener Rally meeting. We are focusing on the 1.139 release today. And we will start with Oliver with a change for the autoscaling of the istio-ingressgateways. Then we have Tim about a change for the static username prefixes when kubeconfigs are requested for shoots. I will show a feature for zone-aware shoot control plane placement in the seeds. And we have Jeremy for the custom domain support for the Gardener Discovery Server. And finally, Sebastian with a new Traefik extension for the shoots. All right, then, Oliver, please get started with the first topic.
Okay, good morning, everyone. I'd like to present you the latest step of our istio autoscaling improvements. We introduced, we're facing some issues with the autoscaling of istio-ingressgateway, especially when we were using the layer 7 load balancing. And we evaluated the scenario a bit, and finally it's a complex scenario, and but fortunately we have a solution at hand. That's the Kube API server like autoscaling. Vetran had the idea a while back, and we adapted it for the istio-ingressgateway. And but before I go into detail, I'd like to show you the motivation of this change. So we were testing the layer 7 load balancing for quite a while, started with seeds which are not that busy, and not my activity monitor. We started with seeds which are not that busy, and we progressed to seeds which are more busy. And after a while, we found issues at our control planes of shoots scheduled at the seeds. You see here a screenshot of the network problem detector, and especially the HTTPS latency to the Kube API server. And let's say at here at about 2 o'clock here, when my mouse is moving, we fixed the issue. Before it was like the old autoscaling status. And you see here at the y-axis, it's the latency goes up to 35 seconds here at the top, and it's in many cases, up to 5 seconds, and this caused lots of problems with the control planes. Basically we found out that the istio-ingressgateway were scaled to their limits. So they're scaled horizontally to their limits. They had a concurrency limit of 4. And this was also exhausted. So all the CPU power was exhausted, and the latency went up. And after we fixed this, gave it more CPU power, we see there's a nice low latency again. Okay, let's get back to the PR. The thing here is, of course, we could adapt the autoscaling in a way to especially support this scenario of very big seeds. But there are also other seeds where the Kube API, which hosts shoots where the Kube API servers have only little use, and then we would waste some resources and money with those big istio-ingressgateways. And We found a similar problem we already solved for the Kube API server, as I mentioned, and which is using HPA and VPA in a combination. And the key thing here is that the VPA is updating CPU and memory, and the HPA in this case is just scaling based on CPU, but it's scaling based on the average value and not on the average utilization. And this way they work nicely together. And yeah, we will see this hopefully in the future. Yeah. Additionally, we also adapted the target values and so on. So the average, when we have two cases, like without layer 7 load balancing, we want to have istio-ingressgateway pods with 2 CPUs, average value of 2 CPUs, while for layer 7 load balancing, the CPU load is much higher. So it's like 4 CPUs. And we also increased the maximum values of horizontal pod autoscaling. So let's say in an HA seed with 3 zones, we have a maximum of 48 istio-ingressgateways now. Okay, I'd like to show you a bit of a demo. Unfortunately, I cannot scale istio-ingress on my laptop in that way that it's or I cannot create so much load that it really scales. Otherwise, all my connections are exhausted. But at least I can show the status quo. So on here my local setup, we see it's the runtime soil cluster. We see all the istio-ingress gateways, and they have little load because there's nothing happening. But I just want you to walk through the objects which we're changing. So we have the VPA, and the key thing here in the VPA is that it's controlling CPU and memory now, and also like the HPA, and the HPA is based on the average value, and I said here average value targets 4. Okay, as I said, I cannot put so much load on my local machine to really see it scaling, but I brought you a couple of screenshots of our tests. So let me put them. That's the first one. That's okay. Okay. So here you see one of our seeds, which has partly heavy load. So the default istios have quite a heavy load, while the zonal istios, they are not in use. They only have very little load. And here you see the problem. So we have like 6 CPUs on top of one istio, and like 8 milli-CPU for very lazy pods, and everything in between. So it's very hard to it's not possible to find a static value which fits all of these requirements. And when you check like the VPA status, so this is now working quite well. don't want. Yeah. On the left-hand side, you see the VPA of the busy istio, and it's scaled up to like 3 point something CPUs and almost 3 gigabytes of memory. And here we have only little CPU load. And the same for the HPA. So the busy istio is scaled up to 10 replicas, which means the average value of 3, and the lazy one is just at the minimum. Yeah, and with this scenario, we hope that we find a solution for autoscaling for both pods, for all the types of istio loads, heavy load and lazy load. Yeah, it looks promising in the test results the tests we carried out so far. Yeah, and let's see how it evolves. And maybe I can present an update in our next iteration of istio autoscaling. Yeah, any questions?
Apparently not. Then thank you, Oliver. And over to Tim for the changes in the username prefixes for the kubeconfigs.
Yep, thank you. Hello, everyone. Let me prepare the demo. Okay. All right, so I want to say a few words about this change, which introduces static prefixes for the admin in fewer kubeconfig requests, so one for each use case. Yeah, I would dive into the demo directly to show you that. So what I'm currently I'm in a garden cluster, and let's check who I am first. So what is my principal to connect to the garden cluster? I can do this with this kubecontrol command, and currently my username is simply Tim. And what I can do with this, so I'm in this case I'm the admin for this in this garden cluster, and what I can do then is to create a kubeconfig request for a test shoot that I have in this garden. So I'm going to do that. I'm going to start with the admin kubeconfig. So I'd like to request, as the word says, a kubeconfig, which gives me administrative rights for this local workerless shoot cluster that I have. Save it to some place, and yeah, let's do that first. We have a script in the Gardener for this, so it's saved. The kubeconfig was requested and issued. After that, I'd like to use this kubeconfig for the shoot cluster and check the identity here as well. So I do this by using the kubeconfig with the same auth command that I already used in the first step. And we can see now that I have a static prefix, which is in this case Gardener Cloud Admin, because I requested an administrative kubeconfig. And the last one is taken, or it's the user which was used to generate the kubeconfig. Right, so this is for the admin kubeconfig request, and I can do the same for the viewer kubeconfig request. So this time I want to limit the permissions in the cluster for the kubeconfig. So I'm going to do this with the viewer kubeconfig. Save it also here. And let's check the identity here as well. And this time it's saying viewer instead of admin. So it's a very easy change, I would say. And the motivation for this change can actually be boiled down to two scenarios. So one scenario is whatever tooling you use for audit logging or access logging, the username or the user principal already gives you a good idea which role was used to connect to the cluster. So it's very convenient, I would say. And the second use case is we have predefined roles for admin and viewer. So admin obviously gives you the cluster admin access. Probably won't change anything about this. However, for the viewer kubeconfig role, we have some, let's say, expectations how a viewer scope should look like. And you might end up in situations where you want to extend the permissions or enhance the permissions in some way. And with this static prefix and the username, you can enhance the permissions then and only targeting this user principal. So there is already an issue open in Gardner discussing this. In this case, enhancing the viewer kubeconfigs to be able to connect to the kubelet debugging endpoints. So this is one example. Yeah, exactly. Okay, maybe one thing worth to mention is before this change, we already had a prefix in place, but it was just a random 10-character string. So you couldn't guess, or it wasn't able to enhance then the permissions that I just talked about. So this is why we switched over to a static one in this release. All right, I think that's already it from my side. If you have any questions, please go ahead. Otherwise, let's get back to Raphael.
There's one question in the chat from Benedict. So about whether the idea is to increase CI/CD compatibility with these new kubeconfigs.
Not sure what the ICD compatibility means in this case, but if you use a service account in your CI/CD and want to execute special things in that shoot clusters, then the answer is yes. So it gives you the option to enhance the viewer permissions. Hope this answers the question. Otherwise, please get back.
Yeah, sure. Thank you.
Thank you.
Okay, thanks, Tim. Then let's continue. The next topic on the agenda will be presented by me, and it is about this zone selection setting for seeds. So the background of this is that when you have a multi-zonal seed cluster, so a seed that is spread across multiple availability zones, and you then create a shoot that is scheduled on the seed, Gardner is picking a random zone for the control plane of the shoot. And yeah, this is fine for most scenarios because there's also this interesting mapping that hyperscalers are doing. So what you see in your hyperscaler account as zone A is in the end mapped to some real physical location, and this mapping might be different in another account. So zone A is not always the same physical data center in the end. So this is the reason why we always went for this random selection approach and didn't offer any more configurability. But in some scenarios where you control the infrastructure, maybe you have an OpenStack installation or some other custom infrastructure, and you know that this mapping in the background does not exist, you might want to control also the zone for your, for example, infrastructure shoots. So this is what this feature is about. Here's also the documentation on the Gardner Cloud websites. Important is that it only has an effect for non-HA shoots and HA shoots with failure tolerance type node, because these are the clusters that always run in exactly one availability zone in the seed. Shoots with a failure tolerance type zone are already spread, so there it's not applicable, this feature. Yeah, so here's again the background information that I just explained, and the way how you can now enable it is in the seed. There is the spec settings zone selection that operators can specify, and there you can select two modes, either prefer or the other mode is enforce. And what is happening, so let's go over the prefer mode. You have a single zone shoot. So yeah, your worker pools are in, let's say, zone A, but your seed is multi-zone, and the zone A is also there. Then you can now, with this mode, enforce that the control plane is also being deployed in zone A. Previously, it was just randomly picked from ABC. It could be anything. For the multi-zone shoots, where your workers are already in multiple zones like AB, and the seed also has multiples, it's like before, just a little bit better in the sense that the zones that are present in the shoot workers are now chosen for the random selection instead of the complete seed zone list like before. And if there is no overlap, so you have some other zone that is not in the seed list, then we fall back to the random zone selection in the prefer mode. And for enforce, it's more or less similar, except for this fallback in the no overlap scenario. So in this case, when you want to enforce that the zone is in that the control plane is in the same zone, then the scheduler would deny to schedule a shoot in this scenario. Okay, let's jump into a demo. I guess then it's getting even more clear. So here I have prepared a multi-zonal seed cluster with the zones 0, 1, and 2. This is my seed. And in my cloud profile, you can see that the shoots generally can also be in other zones like 3, 4, 5, where the seed doesn't have any workers. And for the demo, I'm just creating a shoot non-HA where I specify one of the zones. So I choose 2. And the seed setting is currently not enabled. So it's basically the mode like before. And when I now try to create this shoot, I should get a namespace. Here it is. And when we check the namespace, then now the zone 2 was selected. So this was actually random. It could also be some other one. So let's create another shoot. Now it's zone 0. So there is no guarantee whatsoever. Now we go to the seed and go to the settings part and enable the zone selection. And we go with prefer. So we maybe do now the scenario that the zone that we use here in the shoot also exists in the seed, like 2, which is the case. We create the shoot, check again to which zone it was scheduled. And now it's always 2. So I can do this hopefully very often, and it should always be 2. Let's check. So those are all the shoots that I just created. It's always 2. Which one did I miss? This one. All right. Now I go with my shoot into another zone that does not exist in the seed. So let's take 4. I created a new shoot again. And let's see where this one ended up. So this is now again in some random zone. So it could be 2. And we create another one. It's again 2. But there's no guarantee anymore because there's simply no overlap. Okay. And yeah, then for the last demo, we changed the mode now to enforce, meaning that with this spec here, we cannot run the control plane in the zone 4 because the seed doesn't have zone 4. And we would expect the scheduler to deny the scheduling. So let's create the shoot. And we would expect to not see any namespace here because the shoot was not even scheduled. And when we check the list of the shoots, you see that it's pending. And the scheduler is telling us that none of the seeds has a zone overlap with the shoot worker pools. And because of the enforce mode, it cannot do anything. Yeah, so this is basically what this feature is about. I said it mostly makes sense on infrastructure where you also control the infrastructure itself. Like on hyperscalers where there is this mapping, it won't work reliably. So of course, this mapping will work on the Gardener side, but you might still end up in different physical locations on the infrastructure. Okay, that's all I wanted to show. Are there any questions? If not, then thanks. And we continue with Jeremy with the custom domain support.
Thank you. Let's see for the right screen. Yes. So hello, everyone. I'm Jeremy. It's my first review today. I'm going to present PR I did together with Tim Ebert, doing a small RP change to the garden spec for the discovery server, which already existed. And the discovery server basically exposes the OIDC well-known endpoints. So it has to be publicly available and also immutable. So the thing is currently the endpoint is determined from the virtual server, the domains, which you can see in the specs here. So it's basically the first entry of the domains. And it's generated by prepending it with discovery. So it's discovery dot in this local setup, then virtual garden dot local garden cloud. And there was no way to change that. And because it's customer facing and immutable, you might want to select an own. And that's what you did in this PR. And for that, we adapted the spec with new fields. And that's what the PR does here. And it's small RP changes, but we had some discussions to just see how this interface is affected. The whole thing is integrated into the normal Istio gateway, so it's exposed, even if it's not the same virtual, normal this domain you have here. So if it's a different subdomain, for example, it's integrated so you can access it. And then the same thing is already also included in local setup. We make already use of it, which I can show you in the demo. And the whole thing is complemented with a bit of validation code. So it's the small interface change and also validation logic so that you, even if you choose a custom domain name, that you can't change it afterwards, because otherwise it will invalidate existing workload identity tokens, which call this endpoint to check if the workload really is what it's supposed to be. And if you could randomly change that, that's a security issue. So you have this immutability to avoid breaking things. And also we included this TLS secret name where you can include your own certificate for calling the discovery server, because there's an SSL pass-through. So currently it either uses the wildcard certificate you have in the Garden namespace, or a self-signed certificate. And here we give the possibility to the operator to provide an own certificate, either by cert manager or by using the cert management from Gardener. I prepared a small Gardener using the local setup, where I had to use the operator setup, because we make use of the garden spec. So basically I did this operator up. I already installed the discovery server with the custom domain, because it takes a few minutes to set it up and to reconcile, so it would take too long. And we can see in this garden that we have the garden discovery server listening to this discovery local garden cloud and using our own certificate, which I just opened. Created using OpenSSL and then pointing it to this secret. So what we can do to check that everything works as expected is we can now curl this endpoint. We see we can reach this custom domain, which is in the local setup ensured by creating the DNS records, and in the normal productive setting, we also adapt the gateway to ensure allowing access to this domain. We have the virtual service that work with it, so we adapted all the necessary things to work with it. And if we try to change this domain to, for example, this changed local garden cloud, we get an error because it's immutable. But what we can do is we can change, for example, the certificate. For example, if I put it to null, we resort back to either the wildcard or the self-signed. And what we can then see is the pods are restarting, and when they are restarted, we can just echo the certificate, and we see that's the old one, I guess. I have to wait a bit. Yeah, it takes a while, but you can change it. But the whole thing is the domain is protected. If we take a new discovery server, we can change our own domain, which is a nice thing because it's immutable. So the first time we can change something, we can change something vendor neutral to something vendor neutral. So it's apart from the dashboard, Plutono, and so other things which don't need to be customer facing necessarily. And so that can be changed now. And now you see again, it uses the self-signed certificate, which is the fallback for the discovery server if we don't have this wildcard certificates. Yes. Are there any questions? I just want to post a few links to the chat, which is the PR, a bit of discussion, the motivation, a context on the discovery server, because that's a big topic which I didn't touch here, and also the garden spec that changed. Thank you.
Thanks. Great. Okay, then last session for today is the Traefik extension presented by Sebastian. Please go ahead.
Okay, then let me share my screen. So as a short recap or a little background on that, last year there was a blog post in Kubernetes about Ingress Engine X retirement, and that it runs out of best default maintenance in March this year. So that is what brings us today. So the introduction of the Gardener extension to Traefik. So when you want to use the extension, so you can do some configuration depending on what you want to do. if you, for example, have used the Nginx, there's also Kubernetes Ingress Nginx mode, which has a feature similarity in regards to the annotation which Nginx has used. So you can migrate to it, and they are supporting a subset of the Nginx annotations, and you can still use them, but there's also a Traefik native way, the Kubernetes Ingress. So in this mode, you only use Traefik. You can enable, disable the dashboard for Traefik, but it's not recommended to use it for a production case, because you also need to expose the API if you enable the dashboards. It's just for testing or evaluation purpose. We have the log level if we need to debug it, and also can set the replicas. So to show you how it's working, I have a Gardener remote set up, and for it, I have declared the extension. So you see here the OC repository and also the image. You can use the latest. Yesterday, we have released the 0.2.0 version. You can configure it if you need anything else, and then yeah, we can deploy shoots with Traefik. So I've created 2 shoot clusters, the V4 and the V4B. The V4 uses Nginx Ingress version, and the V4B uses Traefik Ingress version. So if we check now the control plane, we see that we have, as similar for other extension, the namespace of the extension, where the extension itself is running. If we check the logs, for example, we should see that everything looks great, good. And the extension itself is deploying 2 managed resources. Let me show you Traefik for each shoot. The extension Traefik, which is basically the deployment, which we then deploy in the shoot, also with the configuration and all that stuff. And we have in the seed, with the seed class, the managed resource extension Traefik Ingress DNS, which sets up the DNS record, which we have also for Nginx. We can just check that it's there. Get -a Traefik. Here we see that we now have, in a similar way, the ingress or the DNS record, which points to the service of the Traefik load balancers, that we can reach it. And to show you that it's working, I've created a small example also with who-am-I deployment, similar to what Tim used before. So we have a deployment of a who-am-I service, who-am-I, and the service which basically maps to that deployment. Then we have 2 ingresses. This one is for Traefik. We just use the host and then map to the who-am-I service. And for the Nginx part, to show you that also annotation which you could use with Nginx are working now in this mode. I've set some. I want to do SSL redirect. So when I curl HTTP, I want to redirect it to SSL. And also I did some other configuration. So I configured also TLS. I've created a self-signed TLS secret, so you will see it. So now to show you that it's working. So for the Traefik part, which I've shown you, I just want to do a curl, and then I get the response. So everything is working here. And here for the ingress part, where we do the redirect to HTTPS. So I also have to specify the redirect, and also because it's a self-signed certificate, the -K option, and then we also get the response, so it's working. What's also interesting, I want to show you the dashboard of Traefik and also explain a little bit what Traefik is doing here. So let me switch back. Oops. Refresh. So now we see the configuration with Traefik in the Nginx mode. Basically, Traefik is based on the core concepts around routers, middleware, and services. So basically, when a request comes in, it goes to the router, and the router decides to which service it is routed. The service is responsible to then load balance it and route it to the backend, and the middleware sits in between the router and service, and it basically can alter the requests or responses depending on what you want to do. In the Nginx deployment, which we've seen, let me just go back. What we also support or do, we also install the Traefik CRDs. And if we look at the API resources, you also see now that we can do some configuration, like on ingress routes from Traefik. They exist for HTTP, UDP, TCP, and so on. And we can then create custom resources in the cluster. So if we check what we have configured here, for example, with Nginx annotation, we see here the flow or the processing pipeline, what it's called in Traefik, from router to the HTTP middleware and the service. And that is basically what I wanted to show you. And also I have, for example, we can check the logs of the Traefik port. I have it in debugging mode, therefore it's more verbose. But at the beginning, you also see the configuration, which Traefik version is currently used, which provider that we use the Traefik provider here, and the ingress provider, if we would use the Nginx like in the other, here would be ingress Nginx and all that configuration options. And when something is configured, so in the debug mode, you also see when HTTP routes or are added, or the middleware is changed. So that's it basically about the demo from my side. Any questions?
Apparently not. All right. Then we are done for today. Thanks to all presenters. Thanks everybody for joining, and see you again in 2 weeks. Have a good time. Bye-bye.
Thank you. Bye-bye.
Thanks, bye. Bye-bye.